And welcome to Desk of LADYADA.
Hey everybody, welcome to a Sunday night Desk of LADYADA. It's me, LADYADA. With me is Mr. LADYADA on camera control. And we're here at the Adafruit desk. This is where
we're here to do some engineering to release the Kraken.
I'm ready to... Autodesk is kind of like a Kraken.
Yeah. All right, let's do this. So it's Sunday.
Yes.
That means it's LADYADA o'clock, which is when we get it to a good stopping point on Sunday to share some of the stuff we're up to.
Yes. So we actually kind of enjoyed going for a long walk, so I didn't get as much engineering done as usual, but I did get a STEMMA board done, and it's STEMMA Sunday, so I thought I'd talk about that. I also got some piezo tone stuff happening on the MagTag, because I want to maybe do like an alarm clock, and we learned some things also about audio on the ESP32S2. Yeah. And then we'll wrap it up with a great search. So we'll be here for 25 minutes or so, 30 minutes.
Yeah, we're going to do it.
We'll answer questions also if they come into the chat. And, we're just going to slide into this short week. We've got Thanksgiving coming up. We're going to have some turkey later.
Yeah.
Maybe we'll stream during Turkey Day.
Yeah, public service announcement. In case you're wondering what we're doing, we're just going to stay put. We're going to stay home. And we're going to see folks after the new year. And we're going to have even a bigger and better Thanksgiving next year because we've been all going through this pandemic for the last 8 months. One Turkey Day isn't going to be a big deal, but it does matter because right now the rest of the country, even including New York, a lot of people are starting to get sick. A lot of people are spreading.
Yeah.
And we're going to do our part and set a good example and just stay put. And so if you can do that, do that. If you can't, it's not too late. It's not too late. Use us as an excuse. Just be like, I watched this crazy show online. They're about engineering, and they said it's a good idea to just sit this one out. Yeah. So you can blame us. Throw us under the bus. It's fine.
Totally great. All right, so let's kick it off. Let's go to the computer, and I'll show my STEMMA Sunday. I like to kick it off with a STEMMA Sunday every week, working on the STEMMA board. This week, this one's actually from a bit ago. We had someone email and said, hey, there's these I2C fan controllers. And I was like, I have no idea what that is, but I'm going to look into it. This is actually kind of neat. It's an I2C chip. And what it does is it can PWM control a fan. So it has like one PWM channel output. But it also has an internal temperature sensor. And then this actually connects to an external temperature diode. Not a thermistor, but a temperature diode, which I guess is common in fans. Sometimes maybe it's like embedded into fans or embedded into PCBs, and so you can use that to read the temperature, and it'll give you back the temperature in Celsius. And there's a tachometer. So what's neat is that through I2C you can basically control this fan on, off, speed, and the fan is powered from its own power supply. So like even if the fan is a 12 volt like massive fan, as long as it has kind of the standard 4-pin fan output, you can wire it up. It doesn't plug directly into these 4 pins because, again, you need that separate high voltage power. It's like usually 5 or 12 or 24 volts. But this chip is able to control those. So that's kind of neat. This is the EMC2101. There's chips that have like multiple fan outputs and controls, but I like this because it's like, first off, it's simple, it's easy, and it only does one fan, but like you could always, I don't know, wire up I guess you can't have multiple I2C addresses, but you could use this with the multiplexer, or you could like maybe design your own board for the like 2104 or whatever. If it's popular, if people really like these, I'll make one that has multiple fans. And then this is something that Brian has been working on. Brian does a lot of software work, and got it so that you can see the external temperature. It says is 127. That's because it's disconnected, and it doesn't know the difference between disconnected and just like there's nothing there. So it thinks it's at the max temperature. Internal temperature, it's 23, and if I put my finger on it, it'll heat up a little bit. So you can see it's going up to 28, 29. And then the RPM here, it's really nice. Is it does the tachometer stuff to verify the speed. And there's a PWM output. I actually disconnected the PWM, but when I connect it, you can see that RPM goes down about a half because it's actually doing the PWM duty cycle. So we can maybe make that bigger. So this is with the fan just free running, so about 5,000 RPM, and then connect the PWM, and it's about half of that, 2,500. And we can go to the overhead, and I can show this off as well. So this is the controller with the chip, and then I have just connected with the STEMMA QT cable. And then this is the tachometer line, and this is the fan control line. And then this is, I just grabbed this like $5 fan from Digikey. Oh, is a question?
What kind of fans would it control? Like regular desk floor window fans, or something small like a PC?
These are PC fans. This is a standard PC fan setup. They always kind of have these 4 pins, ground, and then power is separate. It comes from like a separate 12 volt or 5 volt power supply, 24 volt power supply, and then we have the 2 control pins. There's the shared ground, and there's the tachometer output, so that tells you the speed of the fan, lets you know if the fan is halted. And then there's also the PWM input to control the speed of the fan, so you can slow the fan down or speed it up as needed. Of course, it's less loud when it's slower, so that's why you want to slow it down to reduce noise. And then the temperature is a separate sensor.
Okay.
Is that cool?
Yeah.
Okay, great. So this is actually looking good. So I think I'm going to probably send this off pretty soon. EMC2101, and here you can see the product page on microchip. This is a microchip part, and it's inexpensive. You know, it's not too expensive. It's like, I think that's in $1. And it's like this cool weird thing where you can like connect to an EEPROM and like upload stuff to it. I don't know. Anyways, but yeah, it's just like, it's a PWM fan control. I don't know. Cool.
Here's a comment
thing
from Jay. It says, sweet, 4-pin fan control. Right now there's not really a great board that does this.
Yeah, it's really simple. I mean, like, it's just, I didn't even know these existed, so it's cool. All right, so the next app, I was, hold on. So this is the wrong, whoop, sorry, this is wrong. Okay, so I was playing with the MagTag, and let me, hold on. Great. Okay, so I got the code. So I got the MagTag going. Oh, let's go to the computer. Sorry. I got the MagTag going, and we have a library now for it. And one of the peripherals, including the NeoPixels, is a Piezo speaker. And so Phil was like, can you make it play songs? One of the things that we played around this week was the ESP32S2. Could we DMA audio data to the DAC? Because there's a built-in 8-bit DAC. It's not, again, 8 bits is not a lot, but you could do like some basic little audio clips, like, you know, sound effects and stuff. So looking to see if it was possible to DMA to it, which would let us basically play, you know, short audio effect clips in CircuitPython. Turns out actually the DMA is not connected to the DAC, which we learned. The DMA is only connected to like I think SPI, I2C, I2S, and like, you know, the direct memory access, sort of like memory to memory copy. So sadly, you can't use it with CircuitPython to play full audio clips. So Phil was like, well, can you make it do little beeps? And so I just looked online for some code that some MIDI files and converted it. And here is this example. So I'll hold this up to the mic. Hold on. Yeah, of course, I'm using this cool PyMaker thing, but sometimes it crashes. Oh no. Hold on. My live demo. My live demo.
Yay.
Yay. So making little beeps. I like to put a buzzer on a lot of my boards. People who've had the CircuitPlayground know that there's a little buzzer on it, and the CLUE board has a buzzer on it. The PyPearls have a buzzer on it, the MagTag. We basically have this like we have a 5mm and 8mm mini speaker, and I like to toss it on. It's nice and loud. It can do different tones very easily, and it's pick and placeable, which is kind of the best thing about it. And some people have been asking me, hey, like, where do I find that buzzer? The buzzer's actually also now on the Microbit, the Microbit V2. They added a speaker, and they used the same speaker we did because it's a sweet speaker. So people have been asking me, where can I pick up one of these speakers because I want to add it to one of my own designs. And I was like, you can find it on Digikey. And then Phil was like, well, you should do a great search.
It's time.
Where in the
That's right. Every single week we do the Great Search with Digikey. This is where LadyAda shows you how to use the Digikey site to get exactly what you're looking for. And this week, our example is this cool speaker.
Yes. Okay, so let's go to the overhead, and I'm going to show... Sorry, the computer. Mistake. So this is the speaker that we're using. It's like this little square speaker that we pick and place onto our PCBs. And there's basically two kinds of speakers that we use in general. We use either piezos or we use magnetic buzzers. And it's confusing. And even to me, it's like sometimes it's hard to tell if something is a buzzer or a piezo. And they're both called buzzers. So one's like a piezo and one's magnetic, but they both beep or buzz. And also within those types, there's ones that are like set tone, like AC input, DC input. It can be like quite confusing. And so I thought I'd show people some techniques to get your own. The reason I like to use the magnetic buzzers compared to the piezo buzzers is these piezo buzzers cannot be surface mount pick and placed, right? They're through hole soldered onto a PCB. They're very inexpensive. They don't require any extra driving circuitry. You can connect this up to a microcontroller with like a 20 milliamp output, and it can like beep nice and loud. However, the piezos really are tuned to just one frequency. They're not, they're usually like a 2 kilohertz or 4 kilohertz. You can send them any frequency, but they're really only good to like a certain small range. That's usually between 1 to like 8 kilohertz. And they're shrill. They have a square wave. They're either on or off. There's not a lot of subtlety to using a piezo, whereas a magnetic buzzer is actually like a little speaker. And you can send it sine waves. It will sound a little bit better. And you can send it, waveforms, and you can get slightly different tones. It's not as good as a big speaker or even like, the ones that you put in your AirPods or your earbuds, but it's basically the same idea. They're same as the ones that are in earbuds or headphones compared to the piezo buzz, which is really meant for like making squeaks. So let's go to Digikey. And so there's two kind of buzzers, right? You either want to get the piezo buzzer. Some people pronounce piezo in different ways, and I don't even know. It's like piezo or pizzo. I don't know. I call them piezo. Maybe I'm wrong. And so within that, there's a couple things. Basically, you can get the raw elements. And what's funny is like you always see these when you open up a multimeter, because they're always like or like other device that has a built-in alarm clock. They'll have these, basically like built into the body of the electronics, and then they have two contacts. So there's a little piezo discs. When you put an AC current across them, they vibrate. That vibration turns into sound. These are extremely inexpensive in quantity, easily down to like 10, 15 cents or so. But again, these are kind of built into the body of the device you're building. There's also these versions. So that's kind of what I was showing you in the Adafruit shop. They have two pins. The piezo is that flexible disc is inside this plastic piece. There's two pins that come out. Sometimes they have wires. Sometimes they have mounting tabs. All good stuff. And then there's two kinds to watch for, which you can see here. There's single tone that have DC input. Actually, the single tone's a little confusing. I'd say there's DC and there's peak to peak. So if you do DC, it basically means that you give it a voltage and it just makes that tone. You don't have to give it a square wave. It just like does its own thing. It's internally driven. And again, this is called like an indicator, because you just like basically treat it like an LED. When the pin is high, screeching noise comes out of it. Pin is low, it's nice and quiet. Compare that to an externally driven transducer where you have to provide it with an AC signal. That might not be a big deal. I mean, like you're going to usually pay a little bit more for the internally driven indicators because they have a little oscillator. Maybe you want to, and then you don't have any control over the pin frequency, like the audio frequency. Whereas externally driven ones, you can, it's a very common thing with an Arduino or microcontroller. You drive it from a pin or maybe with a transistor buffer, and you can give it, a couple of different ranges of frequencies. So that's kind of nice. But again, these are hand soldered or bulk, or they come with wires. I mean, they can be plenty loud, but they're just fixed in their capabilities. So if you don't want a piezo buzzer, the other option you have is a magnetic buzzer.
Here's a question.
Ask the question.
Can these buzzers only generate square waves?
For piezos, yes. It's really a square. I mean, if you drive with a triangle wave, it doesn't sound like a speaker where you'll actually get a different feel for it, or at least no piezo I've had. Every piezo I've had, it's always been like you push it with a square wave. A sine wave wouldn't do anything to sound different. It's like the movement back and forth. It's like a voltage difference that causes it to flex. But that flexure isn't subtle compared to like a magnetic speaker where you can push the air a little bit or more. You have a little bit more control. Although I'll say not a ton. It's like these little buzzers. They're not really speakers. I mean, they are, but they're very minimal, right? Like you can play chiptune sounds or very simple sound effects with them. Not good for listening to really subtle music or lyrical music. The lyrics would not come through. Okay, so next up, all right, so we look for magnetic buzzers, and this is still in that same section. They're kind of mixed. That's the thing you have to watch out for. Piezos and magnetic buzzers, they end up being in the same category. So let's go for active and in stock items. And then again, there's the kinds that are externally driven, internally driven. So we want the externally driven ones because we want to provide, the sine wave or square wave or whatever wave. And then, you can get these as like speakers, and this is really like a speaker, and these are like, this was a single tone. So let's get ones that are not single tone. Let's go for continuous. And let's go for ones that are rated for like up to 5 volts or so. Okay. Great, now we're talking. So yeah, so like some of these, it looks like a piezo, like it has the pins, but this is actually a magnetic buzzer. So what I'm telling you, it's like, this is a great confusion. But the speaker that I like is this one. So it's, you can get bigger ones. You can get ones that are like, this is the 5 millimeters. This is the one used on the CLUE. And then there's a couple different ones that are the about 8 millimeters square. So let's actually filter down to get to the ones that are about 8 millimeter. The problem is there's like diagonal and then there's square, but we want, about 7.5 to 8.5. So let's apply. Okay, great. So now we're really zoned in. So yeah, there's a couple different mix. I will say that these are a little generic. Nobody owns the idea of having like this square speaker. So you can get them, this one has a top port and this one has like a side port. This one's like really tall. This one has a small photo, but it's basically the same idea. And you can sort by price if you care. So let's just say sort by 500, and then under $1. What's nice about these? I'll tell you the thing I really like about these. First off, they're nice and flat. They're durable. I've never really had one break, and they're pick and placeable, which of course, just for me, manufacturability is worth it. Like, yes, it's going to be much more expensive than a piezo. It's like 2 or 3 times more expensive than a piezo. However, I like that it's pick and placeable and that I can play little sound effects on it that sounds a little bit better than a piezo element speaker. So that's why this is the great search item. The CMT7525, so 7.5 by 7.5 millimeter, and I think 2.5 millimeters tall, as seen on many of our most favorite products.
All right, with that, it's a great search.
Where in the world is that part I need? The great search with Digikey.
All right.
Cool.
And those were all the questions during
Right.
the show. So
Great.
with that is this week's Desk of LADYADA.
Perfect timing.
Perfect timing. And we'll see everybody during the week. We have our full week of shows, but there will not be shows for some of our stuff this week.
Scott probably won't be streaming just because
No Scott, no JP on Thursday.
Yeah.
And we'll be doing our show on Wednesday. And stop by Show and Tell if you want, and stop by Ask an Engineer.
All right.
And
We'll be here. Maybe we'll do a little stream on Thursday or Friday.
Who knows?
Yeah, who knows?
who knows?
Feel
But
for it.
please, folks, sit out this holiday week if you can. There's many amazing holidays that we can all have together. We're looking
Yes.
forward to seeing some of you at Maker Fairs in the future and all of those things, but we can only do that if we make it
We're so
to
close.
the next couple of weeks.
We even have a vaccine. I mean, like we just
Multiple vaccines are gonna be on the
make it
way.
a couple more months. We're doing really good.
You know, whatever happens next.
So many games are out. There's
Yeah.
free stuff you can watch online.
You know, a lot of people in human history and even American history made lots of sacrifices.
You don't have
Sitting
to.
out one day of dry turkey ain't a big deal.
I know.
So consider it.
Get a hamburger instead.
Well, you can just get more turkey later.
Well, if you don't want dry turkey.
Yeah.
All right. Well, thanks everybody. Thanks for tuning in. We will see you rest of this week, and
Yep.
we'll be
See
doing
everybody
Ask
soon.
Engineer and Show and Tell on Wednesdays as usual.
Okay, bye everybody.
Bye, everybody.